Hi there. Today we're solving a coding problem in Haskell, which is a strongly and statically typed general-purpose functional programming language. The problem we're solving is the product of array except self problem. I had solved this problem imperatively some time ago and thought I'd try solving it using Haskell. If you like this video, please give it a thumbs up and subscribe to the channel for more. Let's dig in. So here we have our problem description. Write a function that takes an array nums of n integers and returns an array products where products I is the product of all the elements of nums excluding nums I. We have our solution constraints. We can't use the division operator, and the size of our array is going to be greater than 1. Here we also have our input example and its corresponding output. And here we have an explanation of how we got the output given the example input. So we can begin by writing the function signature of our solution. I'm going to call our function products. And this function is going to take a list of integers and return a list of integers. The key to solving this problem was to create auxiliary lists that would store the forward running products and the backward running products of the input array and multiply the elements between those two lists in order to get us our output. So let's set this up, and then we will go into the REPL to create those two auxiliary, to show how to create those two auxiliary lists and solve this problem. Forward products and backward products. So we're going to use a function called zipWidth, which takes two lists and a function and combine those two lists based on the function. So zipWidth, and the combination function that we want to use is multiplication. And we're going to combine forward products and backward products. Okay, let's start building the forward products list. So first, let's define a test list. Let's use the one from our input example. To build a list where we are accumulating a result and carrying over state from the previous elements of the list, the scanl function is useful for this. So let's use that, where the function we're going to be using to accumulate the values is multiplication, and we're going to start with an initial value of 1. And this is the list of our forward running products. Now this list is one more than we need, so we will apply the init function, and now we have exactly what we need for the forward running product. We also need to do a similar thing for the backward running product, but instead of passing the list as it is, we'll want to reverse it. And there we have our list of backward running products. But it's not in the form that we would want it to be in order to apply zipWidth to get the correct results. So we'll need to reverse this output, and there we have it. So if we take a look at the output of these two expressions, we'll see that if you multiply 24 and 1, we get 24. If you multiply 12 and 1, we get 12. 2 and 4, we get 8. 1 and 6, we get 6. So this is what our function is going to do, and this is what we're going to need to build our forward products and our backward products. You can also note that we are using the same functions in both cases. So we're going to pull that out into its own function, and I am going to call that the init product scanl function, which is a composition of init and scanl given the multiplication function and an initial value of 1. For the forward products, that's essentially all it is. It's init product scanl, taking our input list. For the backward running product, we can compose the reverse function, our init product scanl function, and another reverse function, and pass our input list to it. I think this is our solution. Let's test it out. And it loads. So if we do products on our input list, we should get our correct output. That is a solution to this problem in Haskell. I'll leave the link to the code in the description. If you liked this video, please give it a thumbs up and subscribe to the channel for more. Let me know what you think of the solution in the comments and how you solve it or how you would go about solving it. Follow me on Twitter or Medium at Onel Harrison if you'd like to see my content on those channels as well. Until next time, peace.